In this video, we'll look how to solve some selected questions from chapter 1 functions, subtopic also functions. A function g is defined as gx maps to modulus 4 minus x. Find the range of g if its domain is a, -3, -1, 1, 2. Okay, given a domain, that means given the object, we need to find the image. The range means image, the domain means object. Okay, so we have a function with modulus. So gx is a function with modulus 4 minus x. Okay, so we need to replace each of the object to find its image. So I'll start with -3, x equals to -3. So g -3 equals to modulus 4 minus -3. So you get 4 plus 3, it's 7. Okay, 4 plus 3 7, so 7. So any number, if it's any negative number comes out from a modulus, remove modulus, it becomes positive. Positive number comes out of modulus, it's still positive. So I'll follow with -1. X equals to -1. So g -1, replace the value of x with -1. Modulus 4 minus -1, get 4 plus 1. 4 plus 1 is 5. Okay, move on to 1. So I'll do it here. G1. So G1 is G1. Okay, got right. Place x equals to 1. Okay, so get G1. G1 is modulus 4 minus 1, that becomes 3. Okay, so last one is x equals to 2. Place in gx, becomes G2. Modulus 4 minus 2, you get 2. So we got all the values, all the images for the objects given. So we can write down the range. So range equals to -3. -3, we got the image 7. -1 we got 5. 1 we got 3. 2 do we have 2. So the answer is 7, 5, 3, 2. Okay, that's the range. Now the second question. The domain is given in inequalities, -3 and 6. X is more than or equals to -3, less than or equals to 6, something like we done in the previous video. So I'll show it here. So B. So we need to draw a graph for this. So we have x -3 to 6. So okay, I'll draw a graph, something like this. So label the axis, it's gx and x. Okay, so we need to know, okay, when x is -3, what's the value of gx? We done that in question A, so we can use the same value. X is -3, gx is 7. So x is -3, gx is 7 is here. So I can plot that, maybe sketch. This is a sketch. Okay, it might not be so accurate. Okay, let me make it better. Okay, so it's somewhere here, maybe about that. And what else? Also given another boundary is 6. Okay, so assume that x is 6. Have we done x6 before? No. So x is 6. We need to know what's the value of gx. So I'll replace that in the gx. Modulus 4 minus 6, that's -2. So any number that comes out modulus becomes positive. So -2, you remove the modulus, it becomes +2. x6, gx is 2. So we plot that too. So let's say x is here, gx2 is here somewhere maybe. So we plot that. So point is here. So can we just connect these two, because this is our range 93 to 6? Okay, you shouldn't. That's not the way. You'll have a wrong answer if you connect these two, because this is a function with a modulus. Modulus means any answer coming out of the modulus is always positive. That means gx is always positive. It will never be a negative, because any number comes out of the modulus is always positive. So gx is represented in the y-axis. Therefore, our gx axis is always positive. We don't have negative values of gx. So for a straight line graph, our graph definitely will have a positive value and negative value. But because you have a modulus here, we have something that we call a reflection. Okay, the reflection, that means the graph will be reflected. The negative part of the graph will be reflected to the positive, so that we get all the values positive. So we have to find where does it reflected, which point it is reflected. To find that, I'll just do it here. I can just say it's a point of reflection. So you have to do this if the given function is a modulus that involves modulus. So to find the point of reflection, so this is our function. To find that, you just replace gx equals to 0. So what do you get? So modulus 4 minus x is equals to 0. Okay, gx is assume gx is 0. So modulus goes there, nothing will happen. It becomes 4 minus x equals to 0. So x equals to 4. So when gx is 0, our x is 4. So it's somewhere here maybe. We have a plot here. So now this gives a clearer picture. What does it say? Our graph is reflected actually at x equals to 4. What do I mean by reflection? Okay, I'll show you. So the graph is actually a straight line graph. It will go straight. But then it won't enter the negative part of gx, because with the modulus always are positive. So it won't go down. It won't go down. What happens? The part which goes down is reflected upwards. And I'm drawing until 6 because our range is until 6. So the graph is reflected. So any graph that, any straight line graphs that involves modulus, it's always being reflected. So this is our graph. So from here we can find the range, the images. So what are the images? My area as a constant is between -3 and 6. -3 and 6. So if I shade, a simple shade. So these are the area of constant. So what are the value of gx in this area? So in this area, the value of gx is, it goes from 7 to 0 and back to 2. So it's between 7 to 0. So 2 is also in between that. So I can say range. So it's gx more than 0 or equals to, less than or equals to 7. Okay, so I include the equals to sign. So this will be the answer. Okay, this is the answer for A. Okay, moving on to the next question. Hope you can see the question. Given the function hx modulus 3x minus 6 and the domain x more than or equals to -1, less than or equals to 3, sketch the graph of the function h and hence state the range of h. Okay, so this question directly asking us to sketch a graph. So our x is between -2 to 3. So I can just sketch a graph. So the y-axis I label hx, the axis is as x. Okay. Now, so our range is from -1 to 3. So I'll replace x equals to -1 into the function. So hx, -1. Okay, the function is actually hx modulus 3x minus 6. That's the function. So h -1 is modulus 3 -1 minus 6. -3 minus -6, you get -9, and coming out of the modulus you get positive. So x equals to -1, you get hx 9. So -1 maybe here, 9 is here. I'll try to plot that as accurate as I can. So somewhere here, okay, the point. Now we move on to the next border of the x is 3, so I'll just replace 3, find the value, the corresponding value for 3. h3 equals to modulus 3 minus 6. So you get 9 minus 6 is 3, so it's 3. So x is 3, hx is also 3. So I can say it's 3, maybe it's about here, it's 3. Try to plot that too. Yeah, somewhere here. Okay, so we should know that our graph is not straight. It will be reflected because it involves modulus. So I'll try to find the point of reflection. So I'll just write point of reflection. It's good to write all this because it will give a good impression for your examiner. Okay, point of reflection, as usual, our function is hx modulus 3x minus 6. As I said before, to find the point of reflection, replace hx equals to 0. So you get modulus 3x minus 6 equals to 0. Modulus move to 0, nothing will happen to modulus or 0. So you get 3x minus 6 equals to 0. 3x equals to 6. X equals to 6 over 3. That becomes 2. So when hx is 0, our x is 2. So our x is 2 somewhere maybe here. Hx is 0. Okay, so there's one more point. So with these 3 points, we know very clear that our graph is reflected at 2. And it connects from this point to this point and goes there. So I'll just connect them and this way. Okay, so this is our graph. So they want you to sketch the graph, that's done, and hence state the range of h. They want to know the range of h. So hx, yeah, it's for -1, it's 9. Goes until 0 and then goes up until 3, 4, 3. So our range is between 9 and 0. 3 is inclusive in that, so I can write that range hx is more than equals to 0, less than or equals to 9. That will be the answer. The graph is one answer, the range will be another. Okay. We move on to the next question. Okay, hope you can see the question. Yeah, I think it's better now. Given the function hx 3x plus 1 over 2, find a, the object of 8. So we know the function is hx equals to 3x plus 1 over 2. The object of 8. That means the image is given as 8. They want you to find the object. So the image is given as 8. You know, that's it. So they want you to find the object. So 3x plus 1 over 2 is equals to 8. You need to find x. That's it. X is the object. So 3x plus 1 equals to 2 goes up. Multiply with 8, we get 16. 3x, 1 goes to my right, minus 1, so we get 15. X equals to 15 over 3, you get 5. B, the value of P if HP equals to -4. Okay, so the HP equals to -4. HX is this. HP is 3. Instead of having X, we have P. In the place of X, you just replace P. Plus 1 over 2 equals to -4. So 3P plus 1, 2 goes up, you get -8. Okay, 3P minus 1. Plus 1 goes to my right, it becomes -1. -8 minus 1 becomes -9. P equals to -9 over 3, -3. So P is -3. Solved. And the last one, C. The object which maps onto itself. The object which maps onto itself. What does that mean? That means HX maps on itself. That means the image is X. Okay, it maps onto itself. So what is our HX? HX is 3x plus 1 over 2 equals to X. You need to find the value of X. So it will be Tx plus 1 equals to 2 goes there, becomes 2x. I'll bring the 2x to my left. So 3x minus 2x equals to 1 goes to my right, -1. This one x equals to -1. Oh, solved. Yeah. So this is the answer. See you again in the next video. Bye.